Is 8C, and this is the fifth episode on this exercise. We are working on the solution of the course book, and the maths we are studying is Cambridge International AS A Levels Maths 9709. So in this video, we are going to do the few last questions of the exercise 8C. So let's start. This is the fifth episode on this. Today we are going to start from the question number 13, and let me show you the questions. The question number 13 is the question number 13 that is showing up on your screen. The diagram shows an open water container in the shape of a rectangular prism of the length y centimeter. The vertical cross section is an isosceles triangle with the side 5x centimeter, 5x centimeter, and 6x centimeter. The water container is made from 500 centimeter square of the sheet metal and has a volume of V centimeter cube. Express y in terms of x and then show that the v is equals to 600x minus 144 divided by 5x cube. Find the value of x for which the v has a stationary value. Show that the value in the part C is a maximum value. So this is the diagram which we are talking about. It's an open water container. The dimensions are given. The surface area is also given. So question number 13, we are going to attempt. Okay, so let's start. So first of all, it's like a prism. Okay, so we can let me draw. This is question number 13. We are going to start. Question number 13. Okay, so this is basically like this shape. Okay, this is 5x, this is 5x, this whole thing is 6x. So because it is given that this side and this side is equal, so in an isosceles triangle, so this will be 3x, this side will be also 3x, and this will be your right angle triangle. Okay, so I can find this height. Okay, so let me call it, you can call it anything. For example, let me call it the h. Okay, so I can apply the hypotenuse Pythagoras theorem. So it will be hypotenuse square equals to the perpendicular square plus the base square. Okay, so this will become 25x square equal to h square plus 9x square. So the h square will be equal to 25x square minus 9x square. So the h square will be equal to 16x square. So the h will be equal to 4x. Because it's a length, so I'm not taking the negative. Okay, when you take the square root, it is when you take the square root, the answer is positive and negative, but we are taking only the positive because you know that it's a length, so it cannot be negative. Okay, so then this is the base of that prism, remember. Okay, so you know that the surface area of the prism is given to me. That is, it's an open container. Okay, so let me show you the diagram. This is the diagram of that. It's an open, there is no top. Okay, it's an open water container. It had walls. So two walls are triangles, two walls are rectangles. Okay, so let me find the area of this triangle now. This is a triangular wall. The area of the triangular wall will be area of the triangular wall. let me call it A1, will be equals to 1 by 2 into the base, it's a triangle, and the height is 4x. So the area will be 312x square, okay? So the area of this triangular wall will be, the area of the triangular wall will be 3x square. Now, I will find out the area of that rectangular wall. The area of that rectangular wall, that will be length into width, that will be 5x into y, okay? 5x into y. The area of the rectangular wall, that will be 5x into y. So that is 5xy, okay? Now, because this is an open container, so there are two rectangular walls. There are two rectangular walls and two triangular walls. This is the shape, okay? It's an open container, so there is no top, okay? So what I will do, the total surface area, I mean the area of the metal, equals to 2 times the area 1 plus 2 times the area 2. Let me call this area 2. This is area number 2, okay? So area 1 is 12x square and the area 2 is 5xy. So this will become 24x square plus 10xy. In the question, they have told us that the area of the metal used to make that container is 500 centimeter square. So this is already given to us that the area of the metal used to make that container is 500. It is given, okay? So I want to find out the y in terms of x, okay? So it will be 10xy equals to 500 minus 24x square. So y will be equals to 500 minus 24x square divided by 10x. We can give this 10 to means under all of them. But in the book, the answer is 500 minus 24x square divided by the 10x. Okay, so this is how you will represent the y in terms of x. Okay. Now, then their question is show that they say that their question is we have to express the y in terms of x. Then their question is show that the v is equals to this. Okay, if you want to find out the volume of this prism, okay, volume is the base area multiply the length of the prism. Okay, so the length of the prism is y. You know the volume of any prism is base area multiply the length of prism. Length of the prism. Okay, so the volume will be equal to, what is the base area? We just found that area of the triangle. This is the base of that prism. Okay, that is 12x square. And what is the length of the prism? The length of the prism means the area, the length between the two bases. So triangle is the base. So the distance between one triangle and the other triangle, if you look at this diagram, that is equals to y. Okay, the distance between one triangle and the other triangle is equals to y. Okay, so the length of the prism is y. And we have the y in terms of, so let me write first y. So then I know that the volume will be equal to, in the place of the y, I will put this, okay? 12x square into the y can be replaced with this. This is 500 minus 24x square, okay, divided by the 10x. Okay, so this x and this x will be cancelled. So what this becomes? 12 multiply, this becomes 6,000 x square minus 12. Let me use calculator. 12 multiply 24. So we have to do, let me check. 12 multiply, I multiplied with the 500. So my answer is 6,000. That's 6,000 x square. Okay. 24 multiply 12, that is 288. Okay, this becomes 288 x raised to power 4, and this whole thing is divided by the 10x. Okay, so the volume will be equal to, you separate it. So when you bring it here, 0 0 cancel, so it will be 600. There was an x square here. Y in terms of x. Okay. So let me check. The value of the y is correct. The value of the y is 500 minus 24x by 10x. Okay. So the area of that triangle is 12x square. Yeah, that is true. And we multiplied it. Okay. Now this will become 600. How much is left? Let me write it first, then we can separate it. Okay, 10x. Okay, minus 288 x raised to power 4 divided by 10x. Okay, so this will be, how much you will be left with? 0 0 cancels, 600 x minus, so you are left with 288 divided by 288. I want to write it in fraction. So in the fraction, 144 x cube divided by 5. So this is the number. This is that number. Volume is equal to 600x minus 144 divided by 5x cube. So we have found the same thing. Okay. Then their question is the C part, find the value of x for which the V has a stationary value. Okay. So now I have to find out the value of the x for which the V has a stationary value. For that purpose, we have to derivate it. Okay. So we can easily derivate it. dV by the dx will be equals to, this will be 600 minus 144 by 5 into 3 into the x square. So at the stationary point, you know that by dt dx will be equal to 0. So let's make this equal to 0. This is 600 minus 3 2s are 12, 3 2s are 12, 3 4s are 12, 12 plus 1 13, 1 3 1 are 3 3 and 1 4 divided by 5 x square equals to 0. This will go to the other side. So you will have 432 divided by the 5 minus x square minus 600. Minus gone. So the x square will be equal to 600 into 5 divided by the 432. So the x will be equals to, let me do the calculation. What we will do, this is 600 multiply 5 divided by 432 equals to, this is 6.9. And then we have to take the square root, okay? It is 6.9 approximately. Or if you want to, because they have not written in the fraction, they have not written in the decimal fraction, they have written in this form. So this will be something like 125 divided by the 18. So when you will take the square root, so the x will be equals to 125 square root will be 5 under root 5, and 18 will be it's 3 under root 2. Okay, so this is my x value. So because I'm trying to match the answer with the answer given in the book. Okay, so then they have rationalized it. So it will be 5 under root 5 divided by 3 under root 2 multiply under root 2 divided by under root 2. So this will be equals to, this becomes 5 under root 10 under root 2 multiply under root 2, that is 2, 2 multiply 3 is 6. This is the answer which they gave in the book. They rationalize it, okay? In decimals, our answer simply can be same. But you know, I am trying to make the answer exactly like the answer given in the book. So in the book, they say the C part 5 under root 10 divided by 6. So at this value of the x, there will be a stationary point. Then in the D part, he says, show that the value in the part C is a maximum value. Okay. So if you want to show that this is a maximum value, you have to find the second derivative. Okay. So now I know the first derivative. The first derivative is this one. Okay. The first derivative is given to me. dv by the dx is equals to, it is 600 and minus 432 divided by the 5 and x squared. So this is my first derivative. So if I want to find out the second derivative, I will derivate it again. So it will be dv by dx, d square v by the dx square, and this derivative is 0, 4, 3, 2 divided by 5, the 2 and the x. So d square v by the dx square will be equals to 2 2s are 4, 2 3s are 6, 2 4s are 8, 5, and it's a negative sign here, and it's x here. Okay. So put this value of the x there. So at x is equals to 5 under root 10 divided by 6. So d square v by the dx square will be equals to minus 864 divided by 5 multiply with the 5 under root 10 divided by 6. Whatever its answer will be, that will be a negative answer. So if your answer will of the second derivative, when you put the value of the x there, is negative, that means it's a maximum value of the v. Okay. The value of the v will be maximum because the second derivative's answer is negative. So it means that the v value will be maximum at the x equals to 5 under root 10 divided by the 6. So this is how you will do the question number 13, and I hope that this is clear to you. This is how we did the question number 13 of the exercise 8C. This is my 5th episode on this exercise. We are doing the course book of the Pure Maths 1. This is AS A Levels Mathematics 9709. The name of this chapter is Further Differentiation. The exercise main topic is the practical maximum and minimum problems. My name is Ferhan Mazher. So let's go to the next question. The next question coming up on your screen now, if you're done with this, okay? So let's go to the next one. The next question coming up is question number 14. You see, each question involves huge calculations, and this is possible that we might make a mistake. So we have to work very, very carefully. Even if you make a mistake, don't get worried about this. Making a mistake is normal. Okay, so don't worry about the mistake. But in these questions, even a single sign goes wrong, your whole question goes wrong. Okay, so you have to be very, very careful when you're doing the calculations. Okay, so let's start the next question. The next question is question number 14 of the exercise 8C. There are total 15 questions in this exercise, and this is our 5th episode on this. Okay, so if God gave me chance, we will complete this exercise today. Okay, so in the question number 14 coming up on your screen. So here we go. The diagram shows a solid formed by joining a hemisphere of the radius r centimeter to a cylinder of radius r centimeter and height h centimeter. The surface area of the solid is 320 pi centimeter square and the volume is V. Express H in the terms of R. Show that the V is equals to 160 pi R minus 5 by 6 pi R cube. Find the exact value of the R such that the V is a maximum. Okay, so this is the question. This is the diagram. Okay, question number 14. Okay, so let's start question number 14. We have, okay, so we know this is the basic shape of that. This is question number 14. Okay, this is the basic shape of this height is h and the radius is r. This is the basic shape. Okay, the diagram shows a solid formed by joining a hemisphere of the radius r centimeter to a cylinder of radius r centimeter and height h centimeter. The surface area of the solid is 320 pi centimeter square. Okay, it is given, it's a solid. Okay, it is given that the surface area is equals to 320 pi centimeter. It is given in the question. So now I have to express h 320 pi centimeter square. So I have to express h in terms of r. Okay, so very simple. You know, there are two solids basically here. One is the hemisphere and the other one is the cylinder. The curved surface of the hemisphere is exposed. The walls of this cylinder is exposed and the bottom is exposed. Top of the cylinder is not exposed. So the surface area of this top will be, it will be 4 pi r square divided by 2 plus the walls of the cylinder 2 pi r h. The bottom of the cylinder, that's pi r square. And that whole thing is 320 pi. Okay. You see, 4 pi r square is the surface area of the whole curved surface of the sphere. But we have only hemisphere. So we will have 4 pi r square divided by 2 plus the walls of the cylinder 2 pi r h plus the bottom of the cylinder, that will be plus pi r square. So that is equal to 320 pi. Okay. Now we have to represent the h. So you see there are 4 terms. 1, 2, 3, 4. All of them has pi. So pi will be cancelled. So you are left with only 2r square plus 2RH plus R square equals to 320. Okay. So the pi has been cancelled from all of them. Now, you can divide all of them with the R. So you will have this and this. You can add them up. So this will be 3R square plus 2RH is equals to 320. Okay. I want this H to be alone. So it will be 320 minus 3R square. So the H will be equals to 320 minus 3R square divided by the 2R. You see, I have made that H alone. Now let's see what's the answer in the book. So we can also we can also make the shape exactly like that. Okay. They have given the denominator to separately. Okay. So my H will be equals to 320 divided by 2R minus 3R square divided by 2R. So that will be equals to 160 divided by R minus 3 by 2R. So this is the H in terms of R. H in terms of R. Okay. So that is something like this, 160 divided by R minus 3 by 2R. So our answer is right, sir. This is the question number 14 of the exercise 8C. And we are done with this A part, in which he asks us to represent the H in terms of R. Okay, then he says show that the volume is equal to this. Okay, so let me show you. Question number 14 we are doing. Okay. So he says show that the volume is equal to 160 pi R minus. Okay. So we can find the volume. Volume is very easy. You know the volume of this shape. There are two shapes basically. So the volume will be equal to the volume of the hemisphere, that is 1 by 2 into 4 by 3 pi R cube plus the cylinders is pi R square H. Okay. So the volume of this solid will be equal to the volume of the hemisphere plus the volume of the cylinder. The volume of the hemisphere is 1 by 2, 4 by 3 pi R cube plus the cylinder's volume is pi R square H. Okay. Now I can put the value of the H. We have H in terms of R. So we can put that value here. So what we will do, we will V equals to, so the V will be equals to 2 by 3 pi R cube plus pi R square bracket 320 divided, sorry, not 320, 160. 160 by R minus 3 by 2R bracket close. So what I have done there, I have just substituted the value of the H. Okay. That is 160 by R minus 3 by 2 into R. Okay. So now we can find the V value. The V will be 2 by 3 pi R cube plus this will become 160 pi R minus this will become 3 by 2 pi R cube. So this is my volume and these two are same. So this and this will be cancelled. Oh yeah. No, they cannot be cancelled. They are not same. So this will become 4 pi minus. So this is basically 160 pi R and 9 minus 4. This is minus 5 pi R cube divided by 6. Okay. So these two have been simplified with each other. 2 by 3 minus 3 by 2 2 by 3 minus 3 by 2. So its answer will be minus 5. You can check this on the calculator as well. So let's see. Oh yeah, our answer is right, sir. This is what we were supposed to show. You can look at here. The volume, question number 14. The volume is equal to 160 pi minus 5 by 6 pi r cube. This is what they ask us to show. Okay. So our answer is right. Okay. Then in the B part, sorry, the C part, find the exact value of the R such that V is a maximum point. Okay. So if the V has a maximum value somewhere, first of all, I will have to derivate it. Then I have to find out the R value when it has a stationary point, when we have a stationary point. Okay, so first of all, what I'm going to do is we take this V, that is equals to 160 pi R, and 160 pi R, go. 160, my son is here, so we have to set the camera. Okay, so 160 pi R minus 5 pi R cube divided by 6. So this is the value of the V. So now we are going to differentiate it. So we will derivate it dV by dr. Okay. So the dV by the dr will be equals to, this will become 160 pi minus 5 pi by 6 into 3 into r square. So this is dV by the dr equals to 160 pi minus 5 pi r square divided by the 2. So this is my derivative. Okay. At the stationary point, the derivative will be equals to, at the stationary point, the derivative will be equals to 0. At the stationary point, the dV by d at stationary point, the dV by the dr will be 0. So make it 0. 160 pi minus 5 pi r square divided by 2 equals to 0. So take this to the other side. So you will have minus 5 pi r square divided by 2 equals to minus 160 pi. Pi cancel, minus cancel. So r square will be equals to the 160 into the 2 divided by the 5. So the r square will be equals to. So what we will do, we will multiply 160 multiply 2 divided by 5, that is equals to 64. Okay, so r square is basically equals to 64. So now take square root on both the sides, so the r will be equals to 8. At the stationary point, the r will be 8, and I have taken positive value because the radius is a positive. Okay, now if you want to prove that it's a maximum or a minimum point at r equals to 8, we have to find the second derivative. So my first derivative is here, dV by the dr is equals to how much? 160 pi minus, and this is 5 pi r square divided. This is my first derivative. Okay. Now I'm going to find out the second derivative. D square V by the dr square will be equals to 160. The derivative of 160 is a number, 160 pi, so it's 0, minus 5 pi by 2 into r raised to power 1. So d square V by the dr square will be equals to minus 5 pi r. Okay. So at r is equals to, the r value is 8. So r is equals to 8. So let's see what's the value of the dr square. That will be minus 5 pi into 8. So that will be equals to minus 40 pi. 40 is positive, pi is positive, is negative. So this answer basically is negative. So this is a maximum point. So the value of the v will be maximum at r is equals to 8. This is what we have to prove, I think. Yeah. And the D part, the C part was find the exact value of the R such that V is a maximum. So the value of the R where the V will be maximum is 8. So my dear students, this is how we will do the question number 14 of the exercise 8C, and this is our 5th episode on this exercise. The topic of this chapter is further differentiation. The topic of this exercise is practical maximum and minimum problems. This is the course book of the Pure Maths 1. This is a part of Cambridge International AS A-Levels Mathematics 9709. My name is Ferhan Mazher, and we are working on the course book. We are making videos for those students who are in A-Levels, AS, obviously we are working on AS, whose mathematics skills are weak. So now they need help, and they need to work on the course book. They need help in each and every step. The very brilliant students, they don't need help in procedures. But the weak students, they need help even writing the procedure. Okay? So this is how we have done the question number 14. I hope this is clear to you. So let's move to the next question. The next question is the question number 15, which is the last question of this exercise. Okay? So question number 15. And we hope that this video will be helpful for some students around the globe, and they will find it very useful. Okay? Oh my God. Okay. You see, we don't have that much technology, or we have simple sticker board, and we are working. You see? So now let's go to the next question. Next question is the question. Let me show you the question first of all. The next question is question number 15. Okay. So this is the last question of this exercise. Question number 15 is showing up on your screen. The diagram shows a right circular cone of a base of radius r centimeter and height h centimeter, cut from a solid sphere of the radius 10 centimeter. The volume of the cone is V centimeter cube. Express R in terms of H. Show that the V is equals to 1 by 3 pi r square, bracket 20 minus H. Find the value for H for which there is a stationary value of the V. Determine the magnitude and nature of the stationary value. This is that diagram. Okay? So let me draw this diagram. So this is the question number 15. Okay? So we are going to work on it. Question number 15. So here we have, it's a big sphere. And here you have somewhere a cone. Okay. And this is equals to the R. This is equals to the height. Okay. Now, we have to express R in terms of H. So The diagram I made, it looks like the center is, but suppose that the center is here. So this then will be the radius. The radius of the sphere is 10. The radius of that sphere is 10. Suppose this is the center of that sphere. Okay. So then you will get this triangle. Okay. This side will be h minus 10. This side will be the radius of that sphere, which is 10. This is r. Okay. So what we will do, we will apply Pythagoras. Okay. If this is the center of that sphere, then this side, this portion will be the radius of the sphere. Radius of the sphere and radius of the cone are both different. Okay. So this is 10. So this whole thing is h. If this is 10, then this portion will be h minus 10. Apply Pythagoras here. So you will get, it will be r square plus h minus 10 whole square is equals to 10 and its square. So this will be r square plus it will be r square plus h square minus 20h. Or instead of opening it, let's do it in the other way. Don't open it, okay? Then it becomes easy. Okay, we can find the square root, and we can find the square root. Achha, h minus 10 will be equals to the under root of the 100 minus r square. Okay, so the h will be equals to the 10 plus under root 10 100 minus r square. So I think the h is in the terms of, they are not given us that what we have to represent. We have to, sorry, they said the r, I saw the h. They oh my god. And they ask us to express r in terms of h. Oh my god, sorry. They ask us to represent in not h in terms of, acha, they ask us to represent r in terms of, so then I can open it. Okay, I thought they asked us to represent h in terms of r. I read the question again. They said represent the r in terms of x. Okay, so this will become this is h square minus 20h plus 100 is equals to 100. 100 cancel. So a square is equals to 20h minus h square. So r will be equals to the under root 20h minus h square. They asked us to represent r in terms of h. So it's 20h minus h square under root. I thought they asked us to represent h in terms. That's why I was going on the other side. Now, when I read it again, they say that represent the r in terms of h. So we are done with that. So this is how you do the question number 15's A part. In the B part, he says show that the volume of the cone, okay, V represents the volume of the cone. He said that show that the volume of the cone is 1 by 3 pi r pi a square. We have to show this, okay? So volume of the cone, you know, is this is the A part, okay? The B part I'm going to do there. So I'm going to do the B part here. Okay, we have to show the volume of the cone. The volume of the cone, you know, the formula for the volume of the cone is 1 by 3 pi r square h. 1 by 3 pi r square h, okay? 1 by 3 pi r square h. So the volume will be 1 by 3 pi, h is h, r is this, it's square. So it's like 20h minus h square, and it's square, okay? So volume will be equals to 1 by 3 pi r square h, okay? The r's value I have put there. So I wrote the h first. Okay, now this square and this square root will be cancelled. So the volume will be equal to 1 by 3 pi h into 20h minus h square. So volume will be equals to, we have to show this. That shape is, yeah, this is that shape. Okay, you can take h common from these two. So you will have 1 by 3 pi h square into 20 minus h. We take h common from these two, okay? So this is what they ask us to show, that the volume is equals to 1 by 3 pi r pi a square bracket 20 minus h, okay? This is their B part. In the C part, he says find the value of for h for which there is a stationary value. Okay, now it's very easy. Find the value of the h for which there is a stationary value of the v. Now we are on the C part. In the C part, we have to derivate it. So v is equals to 1 by 3 pi. So this becomes 20 pi and h square minus 1 by 3, and it will be no need to pi and h cube, okay? So this is that v equals to, I will derivate it, okay? So dv by the dh will be equals to 20 pi by 3 into 2 into h minus pi by 3 into 3 into h square. Okay, this is how you will derivate it. And Faris yellow. Okay, so this is my first derivative. So let me simplify this. dv by the dh is equals to, this is 40 pi h by 3 minus pi h square. So at the stationary point, at the stationary point, this thing should be 0. dv by the dh should be 0. Okay? This should be 0. So I will make it equals to 0, and from there I can find the value of the h. So you will have 40 pi h divided by 3 minus pi h square equals to 0. Okay? So I can take pi common, I can take h common. So 40 by the 3 minus h equals 0. When you make pi h equals to 0, you get h equals to 0. If you make 40 by 3 minus h equals 0, you get minus 40 by 3. So the h is equals to 40 by 3. H will be equals to, what is this? 3 ones are 3 threes are 1 by 3. So there are two values of h for at the stationary point. When I made it, I made that dy by the d h equals 0. From there, I get two values of the h. One is h equals to 0. The other one is h equals to 3 whole 1 by 13. The h cannot be 0, you know, because the h is the height of that cone. So its value cannot be 0. So just neglect that 0 value, okay? So 13 whole 1 by 3 value is good, okay? We will work with that. H equals to 0, we cannot take that because the h represents the height of the cone. So the height of the cone is not 0. Okay, so the value of the h for which we have a stationary value of the v, the value of the h is 13 whole 1 by 3. Then the D part is determine the magnitude and the nature of this stationary value. If you want to find out the nature of this stationary value, we have to find out the second, the second derivative. So what we will do, we will take the first derivative, which is equals to the dv by the dh equals to, that is equals to the 40 pi h divided by the 3. Then you have minus pi h and square. Okay, this is my first derivative, so I will further derivate it and I will get the second derivative. So you will have d square v by the dh square, that will be equals to 40 pi by 3, the h derivative is 1, and minus pi 2 will come on the side, power will be decreased, h derivative will be 1. So my d square v by the dh square will be equals to 40 pi by 3 minus, this is 2 pi and h. Okay, so this is my second derivative. So once I know my second derivative, I will put the value of the h, which is 13 whole 1 by 3, and I will check if the answer is positive or negative. From there we can decide if the v value is maximum or minimum. So at h equals to 13 whole 1 by 3, okay, that is 40 by 3. Okay, so my d square v by the dt square will be equals to 40 pi divided by 3 minus 2 into pi. The value of the h is 40 by 3. Okay, so this is same, this is same, this is 2. So your answer will be minus 40 pi by 3. So this is a negative, which means that the v will be maximum at h equals to, at the h equals to 40 by 3. Okay, ji. So their question was that determine the magnitude and the nature of this stationary value. Okay, so the v will be maximum when the h is 40 by 3. Okay, so we have to find the value of the v also. Okay, so where is the formula for the v? This is the formula for the volume. So the v will be equals to 1 by 3 pi h square. H is how much? Or I can use, we can use this formula, 20 by this formula, okay? 20 pi and into a square into 40 by 3 h square. Here you have 3 minus pi in by 3 into 40 by 3 and its cube. So let me find the values. Okay, so now I'm looking at I'm calculating actually that volume's maximum answer. Okay, so let's do this calculation. Very simple, just enter these values in your calculator. So this is 20 pi divided by 3, multiply with the bracket start 40 divided by 3 bracket close square minus pi divided by 3. Then we have multiply bracket start 40 divided by 3 bracket close raised to power 3, or you can say raised to power. Okay, so the answer is 1241. The answer is 1241.12. So they in the book the answer is 1241. The I think centimeter cube or so this is the right answer, sir. In the book the answer is the same. 1241 is the maximum value of the volume. So this is how you will do the question number 15. You see, this is our 5th episode on the exercise 8C from the course book of the Pure Maths 1. The mathematics we are studying is the Cambridge International AS and A levels of mathematics 9709. The chapter number 8 is related with the further differentiation, and the exercise 8C was about the practical maximum and minimum problems. There were 15 questions in this exercise, and we are done. I have done all the 15 questions and uploaded my videos on my YouTube channel. So if you think that this video is useful, if you think this video is helpful, if you think that this video can be helpful to your junior students, to your senior students, to your cousins, please, to your class fellows, please share the link of this video with them. If you think this video is good, please like this video. Also, if it's possible, subscribe my channel. When you like my video, when you subscribe my channel, this provides a support to my YouTube channel. This provides a support for me and for my work. So thank you very much, everyone, for taking out time and watching this video and learning the AS mathematics from here. Thank you very much, everyone. Have a good night, sir. God bless you all.